Hello, my peeps. This Algebra Nation video will cover workbook, page 41, problem number 6.
All right, y'all, we are gearing up for a road trip. We're going on a road trip with our friend Abram. Abram, he's got a cool car. He's got a Ford Fraction. We're taking his car, going across Florida. Now, his gas mileage is given to us in this problem. He starts off with 27 half gallons. What does that mean? 27 over 2 gallons of gas in his car. That's kind of weird, right? We'll deal with that one later. All right, so now we know the amount that he's starting off with. There we go. Now I can see you guys. So we're starting off with 27 over 2 gallons of gas in the car. Okay? For every mile that he drives. So the further he goes, the more gas he uses. That's how a car works. Keep on driving, you use more gas. Well, every mile that he goes, the amount of gasoline in his car decreases by 1/16 of a gallon. That means he drives a mile, the amount of gas goes down 1/16 of a gallon. Drives another mile, goes down another 1/16 of a gallon. Every single time he drives another mile, the gas in his tank is going down by 1/16 of a mile. So if G is the amount of gasoline left, so G is the amount of gas in his car after driving M miles, M number of miles, write an equation that represents this situation. So let's think about this. We're looking at the amount of gas that he has in his car. Well, how much gas does he have in his car before he drives at all? Before he starts driving, fills up his tank, how much does he have in there? 27 half gallons, right? When he first starts the trip, he has 27 over 2 gallons of gas. All right, what happens when he drives a mile? What happens? He loses 1/16 of a gallon. Each time he drives another mile, he loses 1/16. What happens if he drives another mile? He loses another 1/16. Every time he drives another mile, he loses 1/16. So if he drives M miles, how much gas has he used? Well, the number of miles times 1/16 per mile. We use 1/16 times M. 1/16 per mile. For every single mile that we drive, we're using 1/16. If we don't drive any miles, what happens? Well, we're not using up any gas. If we drive 1 mile, well, 1/16 times 1 mile would just be 1/16 gallons. What about 2? Well, if we drive 2 miles, we're using 1/16 gallon for the first one, 1/16 gallon for the second one. 1/16 times 2, well, 1/16 plus a 1/16, that's the same thing as saying 1/16 times 2. You get 2 over 16, or 1/8. 1 over 8. So we know that the amount that you use is 1 over 16 times M. You use 1/16 of a gallon per mile that you drive. Now, is that amount of gas that you're using adding to the amount of gas in your tank, or is it taking away from the amount of gas in your tank? Well, you start with 27 over 2 gallons. You're starting with a certain amount of gas. Drive a mile, do you know how more or less gas than what you started with? Right, when you drive, you're using up more gas. You're taking away from the gas that you had. You're using it. So the amount of gas that you're going to have in your tank, you're starting with 27 over 2 gallons. But as you drive, you're taking away 1/16 gallon per mile that you drive. We're taking it away. We're subtracting off this amount of gas. So what are we looking at this equation? Well, we have G, the amount of gas in our tank. Well, what's the amount of gas in our tank? Well, it depends on how much we've driven, right? It depends on how many miles we've gone. Now, we're going to start off with 27 half gallons. And then we're going to take out another 1/16 gallon for each mile that we drive. That's it. We've got our equation. We've got an equation representing G, the amount of gas left in the tank after driving a certain number of miles. All right, let's look at our next question. It says, if Abram checks his gas tank and realizes that he has 5 gallons left, how many miles must he have driven? What are we told here? He has 5 gallons left. 5 gallons left. Is that telling us the amount of gas in his gas tank? Or is that telling us the number of miles that he drove? Well, it's telling us the number of gallons that he has left. Staying right here, G is equal to 5. He's got 5 gallons left in his tank. Well, what was our equation? We got our equation right there. Let's just rewrite it. We had G equals 27 over 2 minus 1/16 times M. Well, we were told that G is equal to 5. If he has 5 gallons in his tank, right, we know he has 5 gallons in his tank, he started off with 27 over 2 gallons. miles did he drive? We're trying to solve for m. That's all we did. We set up an equation. We know that we have 5 gallons left in the tank. Well, if you have 5 gallons left in the tank, you started at 27 over 2. Well, how many miles did you drive? He was taking away 1/16 for each mile that he drove. How many did he drive? We're going to figure that out. So what do we want to do? All right, first off, we're dealing with some fractions, right? So we're going to have to deal with those. And I hate fractions more than anybody, but we can deal with them. And they're not going to be that bad. Let's just always keep in mind what we're trying to do. It's just the solving problem, trying to get that variable by itself. So what do we have here? We have 5 is equal to 27 over 2 minus 1/16 over m. Well, this 1 over 16 times m, are we adding or subtracting anything from it? We have this 27 over 2. Is this a positive or a negative 27 over 2? It's a positive. So how do you get rid of a plus 27 over 2? Right, we're going to subtract. We're going to subtract 27 over 2. And whatever we do to one side, I like to draw my wall, we got to do to the other. So when we have a problem and we're solving for x, and you're doing like 3 minus 2, that one's easy, right? You can do that in your head. But you probably can't do this in your head. 5 minus 27 over 2, right? I can't do that in my head. We're going to do that over on the side. We're trying to do 5 minus 27 over 2. Well, when we're subtracting fractions, what do we need to do? We need to make sure that they have a common what? Denominator. The number in the bottom of the fraction needs to be the same for both of them. Now you're saying 5 is not a fraction, but we can make 5 a fraction, right? How do we do that? 5 is the same thing as 5 divided by what? 5 divided by 1. What's 5 divided by 1? 5 divided by 1 is just 5. 5 divided by 1 is the same thing as saying 5. It's just another way of writing it. So now we took our number and wrote it as a fraction. So, all right, we're getting there. Okay, we know that we need to have a common denominator. That means that the number in the bottom of our fraction needs to be the same. So we've got a 1 on the bottom here and a 2 on the bottom here. What's the smallest number that both of them go into? 2. So I need to make this a 2 on the bottom. How do I make this a 2 on the bottom? Let me ask you something. If I start with 5 and I multiply by 1, what do I get? What's 5 times 1? 5, right? 5 times 1 is 5. If I start by 5 and I multiply by 2, you're thinking that's not 5 anymore, right? What if I also divide by 2? 5 times 2 would be 10, right? Okay. 5 times 2 gives us 10. Okay, what's 10 divided by 2? 5. All we were doing right here is multiplying by 1. What's 2 divided by 2? 2 divided by 2 is 1. 5 being multiplied by 1 is equal to 5. Well, 5 being multiplied by 2 over 2 is also equal to 5. 2 over 2, same thing as 1. So what we can do to get a 2 in the bottom here is just multiply the top by 2 and the bottom by 2, because 2 over 2 is really equal to 1. So what are we doing here? When we're multiplying fractions, we take our top, we're going to multiply our tops, so 2 times 5 is 10, over 2 times 1 is 2. So now we have 10 over 2 minus 27 over 2. Okay, when we subtract fractions, am I subtracting my denominators? No, we're keeping our denominator the same. We're keeping that as a 2. What about my tops? I am going to subtract that. I'm going to take 10 minus 27. I've got 10 and I'm taking away 27. Am I going to add up with a negative number or a positive? We're going to end up with a negative, because that 27 is being taken away from 10, and that 27 is bigger. So what is 10 minus 27? 10 minus 27 gives us a negative 17. Well, we just ended up with a negative 17 over 2. So now we have our left side of the equation. We have negative 17 over 2 is equal to what? Well, the 27 over 2 and the negative 27 over 2 canceled out. So we've got this negative 1 over 16m.
Ready for a brain break? Because I am. Hopefully you look like this on the EOC. Oh, look! Raymond, you might want to close your eyes. Looks like they were playing the Lakers. Ouch.
Now what? We want to get this m by itself. Well, m is what? It's being multiplied by negative 1 over 16. being multiplied by negative 1 over 16 is the same thing as writing negative 17 over 2 equals negative m over 16, right? Gives me the same thing, okay? How do I want to get rid of this? If m is being divided, and you know what, we don't even need to write this negative up here. It's the same thing as writing it down here. You can write it either way. This is actually going to make our lives easier. So if m is being divided by negative 16, how do we get rid of that? We're going to multiply by negative 16. And whenever we do to one side, we've got to do to the other. So we're going to multiply both sides by negative 16. Well, negative 16 divided by a negative 16, those cancel out to give us 1. So we're left with m on the right. Well, that's good. The variable is by itself. But what about over here? What do we have? We have a negative 16 times a negative 17 over 2. Well, I have a fraction here and I don't have a fraction here. How can I write this negative 16 as a fraction? I'm going to put it over 1. Whenever I have an integer, I can put it over 1 and it means the same thing. So when I'm multiplying fractions, remember I multiply my tops, I multiply my numerators, and then I put it over my denominator, multiply my denominators together. So negative 16 times negative 17. And negative times a negative is going to give me what? A positive, right? When you multiply a negative and a negative, you get a positive. So what we're doing is 16, make it a negative, times 17, make it a negative, and we get 272. Are we done? No. We still need to multiply out our denominators. 1 times 2 gives me 2. Okay, does 2 go into 272? Yep, 272 is even. So I can divide 272 by 2, and I end up with